Well, it's good to be with you this afternoon. It's a particularly pleasant occasion to be able to share with you some of the things that we see in the rocks out there and how they relate to one of the great conflicts we have. I've been told at times that at my age I should be happy to be anywhere, and I want to assure you I'm happy to be here today. One of the questions that people have is, which is true, the Bible, or science? And these are highly respected sources, authoritative sources of information. Science, highly successful in some areas. Bible, the world's most popular book, accepted by a third of the population of the world as a guide, a moral guide, and so on. And without question, something that is appreciated. And yet these two books, or I shouldn't say these two books, these two sources of information have extremely diverse models of how things came about. Science speaks of evolution over billions of years, no God involved. Bible speaks of God creating in 6 days just a few thousand years ago. And people wonder which is true. Some try to compromise the two by suggesting, well, maybe God created over long periods of time and so on. But these compromise views we'll not spend much time on today. They don't have a good source of authentication. It's not the biblical model, and methodological science does not propose that God created over long periods of time. In the Bible, we're told very plainly, probably the most authoritative book in the most authoritative words in the Bible are the Ten Commandments. These are words that are written by God, spoken by Him, and there He states very plainly what you probably all know. You'll remember the Sabbath day, keep it holy, for in 6 days the Lord made the heavens and the earth and the sea, and all that is in them, and so on. It's an all-inclusive type of creation is described there in 6 days, and then God rested on the seventh day. Well, it would be a strange kind of God, if you're proposing maybe God did over a long period of time, who would create over long periods of time and then tell us, keep my Sabbath because I did it in 6 days. He could give us all kinds of other reasons to keep the Sabbath. It sounds like this is what he meant and what happened, according to these most authoritative words in the Bible. And then you get back to Genesis. First two chapters, it talks about God creating in 6 days, each day, evening and morning, sounds like 24-hour day and so on. It's only that biblical model. It's 6 days recently. On the other hand, when we go and look at the rock layers out there, let's say a picture of the Grand Canyon, we see very thick layers, or these are unusually thick, extremely thick here for the average thickness of sediments over the world. And scientists say, well, evolution took place. For instance, where you see this arrow right now, they would say, well, that's around 550 million years old. And later, higher up in those layers, they would say, well, that's about 300 million years old. And at the top of the canyon there, they say, well, it's about 250 million years old, and so on. And they propose that organisms evolved one from the other through this series till we come to the present. That's the scientific model. So you see the contrast here between the two. You cannot reconcile those two very readily. For instance, when you look at the fossils there near the region of that lower arrow, you find trilobites. They're a crab-like organism. You look a little higher up, you see ferns. And you don't find ferns down where the trilobites are, and you don't find trilobites up where the ferns are. And if you say, well, there's 250 million years between those two as is proposed, there's no way God created all in 6 days. Conflict is obvious there. Those scientists who believe in the creation account in the Bible look at these rocks in a different way. They look at these layers and say, well, it looks like these could have been laid down during the flood. You see, because in the biblical model, God creates man becomes wicked. God has to cleanse the earth by this worldwide flood. And this worldwide flood is the cause of these layers out there. It's the event that reconciles the six-day creation to the rock layers we see out there. But of course, you understand the interpretation has to be greatly varied according to these two models. And the important difference is in time. And so we want to talk about time. We'll be talking about time in several papers this afternoon regarding this. How much time is involved in these layers? Traditional geological timescale would suggest, well, at least for around where it is, Erosion, several hundred million years. The flood model, creation flood model, would suggest no, those layers were laid down during the Genesis flood, which took just a little over a year. And the big question is, when you're asking which is true, science or the Bible, this question of time is a key issue in the thing, and this question of time is what we want to look at. There are some things out there, when you look at them, that suggest, hey, there's not all that much time involved in the laying down of these layers, such as those that you see in the Grand Canyon. Well, one of them is what we call a paraconformity. This is a new term to you. I want to introduce it to you quite gently, but you've got to keep two things in mind. It's not one simple thing. A paraconformity is not one. You have to keep two things in mind to understand the term paraconformity. And I've outlined them there in blue there. You have to have a gap. Where you have a paraconformity, you have a gap in those layers. You can tell you have a gap in those layers because some other part of the world, you got the layers in between those two layers. And you also have to have a flat contact. So flat gaps. Keep those two things in mind as we talk about paraconformities. They have to be flat, and you have to have a gap. Picture of a paraconformity here. What is it? It's just a line. Because it's a gap. There's nothing there. Stuff above it, stuff below it. It's not there. It's just like a hole in a donut. Nothing there. And it's the line right at the end of that red arrow. You can follow it across the picture. It's right at the base of that whitish layer that you see across there. And according to standard interpretations of the geologic time scale, the gap that's between those two is about 6 million years. How do you tell it's 6 million years? Well, it's because if you drive about 150 miles south from here, and this is the Grand Canyon right here, to Silona, Arizona, there's a layer called the Schnebly Hills Formation. It's supposed to have taken about 6 million years to form. And that layer is right in between those two layers at that line. In other words, the Schnebly Hills Formation is just below the white layer and above the darker layer right below it. And so, well, no, there's a gap here of about 6 million years. And what is important in this question that we're raising about time here is that when you look at the darker layer right below the white layer, you should see the evidences of that 6 million years. Weathering, erosion, and so on. Could it sit there for 6 million years and be so flat? This is why paraconformities raise a question about time, because they're so flat. They're these flat gaps. Well, just to emphasize what we're talking about here, the diagram of what you were looking at in the last slide, the lighter whitish layer in the Grand Canyon is the upper layer, we call it the overlayer, and the darker layer below we call the underlayer. And the underlayer, that's the important thing as we are considering the effects of time in the paraconformity. Do we see irregular erosion in the underlayer? Do we see the effects of time, or don't we? Did that 6 million years take place, or didn't it? When it's so flat as you see there in the Grand Canyon, you wonder, did that 6 million years ever take place? Well, the significance of these paraconformities is that they're quite common over the world, and they just don't raise the question about time in one place in the Grand Canyon, one part of the geologic column, but they challenge the whole geologic time scale. This is a very important diagram. Please pay close attention to this. It's a diagram of the various layers just east of the Grand Canyon. It's a diagram, understand, represents about 133 kilometers across. And we've put the various layers in white on that diagram. Various names and so on for those layers. We've also put the paraconformities in there in black. And since this is on a time scale, the thickness of those black layers tells you how much time is represented in the gap by other layers elsewhere on the Earth. Near the bottom of the diagram, you can see a great big dark blackish layer there. That represents about 140 million years, according to the standard geologic time scale. The layers here, according to standard interpretation, would be about 550, 600 million years down at the bottom, going up to 100 million near the top. And where you see a thin black layer, it's not so much time. Where it's thick, it's more time involved. And at the bottom of that thick black layer near the bottom, it's the one next to the bottom, you notice how flat the under layer is, which would be the top of the white layer right above it. Could that remain that flat for 140 million years is the question we're asking today. Or were those layers laid in rapidly during the flood, and there wasn't that time, and so you don't see the effects of that erosion over time? That's where the issue comes in. Just a look at some of the topography of our region tells you how irregular erosion is in that particular region of the world. And you can see it's not flat. And we can tell how fast erosion is going on. It's very easy to determine, actually. It's just a picture of an island here in the ocean. I have 3 rivers carrying water into the island, blue rivers there, and where you see the red arrows, you see sediment coming out of the mouths of the river. You can measure that sediment as it comes out, day in, day out, year in, year out, and so on, and you can tell how fast that river is carrying sediment from its basin into the ocean. And on that basis, knowing the size of the river basin, you can tell how fast erosion is and how fast that island is being eroded away and how long it'll take before that island is completely flattened out. And on that basis, so you can determine how fast are our continents being eroded away. And we get some interesting figures about this, and the rates of erosion have shocked geologists when they started studying them a while back. And Sparks, University of Cambridge, makes this statement. He says, some of these rates are obviously staggering. The Yellow River could peneplane, and that means flatten out, an area with average height of that of Everest in 10 million years. Well, now, if you could erode Everest down in 10 million years, or a region that much more larger than Everest, so we're talking about the Yellow River Basin, in 10 million years, how come our continents are still here with these layers 100 millions of years old, as we've been telling you about? Rates of erosion seem to be way too fast to fit into our standard geological time scale. Another statement from a couple of geologists says North America is being denuded at a rate that could level it in a mere 10 million years, or to put it another way, at the same rate 10 North Americas could have been eroded since Middle Cretaceous time 100 million years ago. Open admission that these rates of erosion, hey, it should have wiped away our continents out a long time ago. It's so fast. Well, geologists have studied the rivers of the world, determined how fast continents are being washed away. This is an important question, of course. And here are 12 studies. Average of those 12 studies would suggest that in 1 year, you erode away about 24,000 million metric tons of sediment. Well, that may not mean much to you, and let's convert it back to, hey, what does that mean in terms of rate of erosion? Because you have to calculate the area of the surface of the Earth and of the continents and so on to do this. And what it means is that our continents are being eroded at about 60 millimeters per 1,000 years. This doesn't sound like very much. You put it on a geologic time scale, of course, and everything should be gone a long time ago because they put in so much time in the geologic layers. But that's too fast because we have agriculture. We cut that figure in half. Studies suggest maybe agriculture has double rates of erosion. We're talking maybe about 30 millimeters per 1,000 years. But then extend over time, of course, that's disastrous because you could erode our continents over 100 times. And they're still here. Well, this is one of those time factors. We're not getting into this one especially today. That suggests it doesn't appear that things have gone on for all these millions of years suggested. Maybe we renew the layers from below. That's the answer you find in a lot of textbooks. We renew these layers from below, and that's why we still have mountains, type of thing. But we haven't gone through one cycle. The mountains show layers that are very old. We haven't gone through one cycle of erosion, eroding it down, and renewing it from below. All right, we have a picture here of some layers in France. And they're Jurassic, supposed to be 150 million years. Why are they still there? If we erode in our constant way at about 10 million years, something is askew here in this. And this relates to what we see as far as paraconformities are concerned. Let's look at some paraconformities here. And we have here a picture looking from Dead Horse Point in Utah. And when you look at those layers there are two paraconformities in those layers there. One of them is about 10 million years old, and it's Triassic. It's the middle Triassic that's missing there, about 10, 12 million years. In 10, 12 million years, according to our standard rates of erosion, you'd expect about 1,000 feet of erosion. So you look in those layers, hey, can I find something that suggests there that? Well, you don't see it. Where is that 10 million year gap? Right at the end of that arrow, you have a 10 million year gap. It's a very extremely flat layer. Did that 10 million year take place? It doesn't look like it. You have all kinds of irregular erosion. Well, that's 1,000 feet of it in that time. And there's another one below that, and you look for some irregularity below. The one below is 20 million years. The Ochoa and Guadalupean stages of the geologic column are missing there. And you look for it. Now you can't see it, but it's right at the end. It's that whitish flat layer that you see all over the place there. 20 million years there. It doesn't look as that ever took place. Well, we can... This is not a local situation. 150 miles southwest of there, near St. George. That same 10 million year gap is there. The 20 million year gap is there, but it's below ground. But you can see the 10 million year gap in the cliffs right there where the arrow is pointing. Grand Canyon, we already talked about that 6 million year gap near the top. Right there. There's a 14 million year gap right below that. You kind of look around 14 million years, you expect on average 1,400 feet of erosion. And you look for some kind of suggestion of paraconformity there. It's right there in the middle of those reddish step-like layers right there. No sign of a gap to speak of, 14 million years. And there's another one, 100 million years old. In the lower part of the Grand Canyon, your Ordovician Silurian. For those of you who are familiar with geological, Ordovician Silurian missing 100 million years. You'd expect 10,000 feet of erosion. And you look for some evidence of that, you don't see it. It's right there, flat. What do some geologists say about these gaps, per se? Here's a couple of experts who studied the Grand Canyon for years. Blakey says, regarding that 14 million year back, he says it can be difficult to determine both from a distance and from close up. Can't even see it in some places to speak of. Speaking of the 100 million year gap below, Buse says, even though representing more than 100 million years may be difficult to locate. You'd expect, 10,000 feet of erosion there, and it's difficult to locate. Well, I can show you all kinds of slides of these. Those of you who've heard my lectures before know I've got lots of slides on this, but let's look at just a couple more here. And, right here, this is near Vernal, Utah. 20 million year gap there. You have the Cedar Mountain Formation above it, and then the Dakota above that. But there's a gap there, 20 million years. Lower Cretaceous and Upper Jurassic missing there. You go 400 miles south, you got the same gap. This is near Gallup, New Mexico. And you look at the layers there, and the gap is not 20 million years, it's 40 million years. Because the Cedar Mountain Formation I mentioned to you in the last slide is not there. And this 40 million year gap. Very flat. You can drive from to the Arizona state line, clear to Albuquerque, follow it for 150 miles, and you see this gap. The Dakota sandstone sitting on top of the Morrison, for those familiar with those things. But it's that gap, you just follow it all the way through there. A little bit of erosion once in a place, hardly any, but in 40 million years, you expect about 4,000 feet of erosion. Well, Owl Creek Mountains, Silurian missing here in those layers right there at the point of the arrow, the tip of the point of the arrow. 24 million years, looks very flat. Tucumcari, New Mexico, 200 million years, right at that flat line you can see across the picture at the end of the tip of the arrow. Your Jurassic, Cretaceous, Paleocene, Eocene, Oligocene, Miocene, all missing there. And yet look how flat the contact is. And we can go Petrified Forest National Park, Arizona, 190 million year gap. More or less the same layers missing there. That one, there is some irregularity. In one place, they find 200 feet of erosion. But 200 feet is about 1% of the amount of erosion you expect over 190 million years. It doesn't look like that 190 million years ever took place. Well, what do scientists say about this? Well, they say, well, it's a question they have a serious question about it. Newell has written about this, and he says the origin of paraconformities is uncertain. I certainly do not have a simple solution to this problem. And he suggested, well, these could be very wide beaches that remain stable, over millions of years type of thing. Not very satisfying, because most of these paraconformities don't have anything to do with beaches. Well, we talked about some of these in the western United States. Are there places? Very definitely. But if time is missing in the western United States, it's missing all over the world. Time is universal around the globe, as you understand. You have 20 million years missing because there's no eroded paraconformity in the United States. It's missing everywhere else, of course. But let's look at some other places here. For instance, this is New Zealand. 3 million year gap, 4 million year gap there. This is Marshall paraconformity, very famous paraconformity. It's found also in Australia, Caledonian Basin. Here's a 45 million year paraconformity in the Rhone Valley in Switzerland. For a dark line right at the tip of the arrow, you'd expect a lot of erosion 45 million years. Very smooth line there. It doesn't look like that 45 million year ever took place. Australia, south of the Sydney Basin, you can see at the tip of that arrow a line, and it sits right above a coal seam, a black coal seam. That coal seam is supposed to be 6 million years older than the layer above it. You have a paraconformity there. How could coal remain there for 6 million years and not be eroded away? It doesn't look as though that time ever took place. And you go to the south of the continent of Australia, you find Kangaroo Island, and that's 160 million years surface there. And it's flat. Kangaroo has a little bump on the eastern side, but it's a very flat island, runs about 150 kilometers, and it's said to be 160 million years, dated by radiometric dating at that. Fossils seem to suggest 160 million years. How could that sit there for 160 million years and be so flat? You'd expect miles of erosion during 160 million years. It lies there very flat. Well, in Venezuela, one scientist was studying layers, and he looked at There's supposed to be a 15-millimeter gap, and he says here, but even the closest inspection failed to turn up the precise position of that 15-millimeter gap. Questions about paraconformities. Could these just represent widespread flat areas of the Earth? We have very flat areas in certain lakes. We have very flat areas in the abyssal plains of the ocean. We don't seem to have them elsewhere of any significance. Could these represent those things? No, they don't represent lake deposits, certainly not widespread lake deposits. They don't represent the deep ocean in any way. Second question, could these be areas where there is no erosion or deposition? There's probably no significant area of the Earth where you don't have deposition or erosion because you have weather all over the place, especially over a million years. You have movement of the continents, uplift and downdrop and so on. We should have lots of examples of these all over the Earth since they're so common in the fossil record. Well, another question, can we have flat erosion? Well, geologists used to postulate this about half a century ago, but they kind of gave up. The peneplain concept it was, they kind of gave it up because it's, those plains are non-existent. You don't see them anywhere. Because these gaps have been protected by overlying layers. And yes, they could be. But when you eroded them out, they would not erode out flat. Many, they're very soft. I show you something. They're very soft. You're not going to stop right at that plate automatically. You're going to erode. It's not going to be flat. Another question, is there evidence of erosion at these gaps? Yes, a little bit. I talked to you about it a little bit. It's minor compared to what you'd expect. If the gaps were underwater, would this not protect them? No, not at all. A lot of erosion goes on underwater. Well, conclusion about paraconformities. Because paraconformities are so abundant over the Earth, they represent an important component for the interpretation of Earth history. You got to explain these things. Paraconformities pose a serious challenge to the standard geologic timescale, radiometric dating, and interpretation of extended time for the development of the Earth, of life on Earth. And finally, paraconformities are flat gaps, are what would be expected from the rapid deposition of sediments during the Genesis flood. In concluding, let me just get back to this diagram I mentioned right here. Notice how common these paraconformities are, all these black layers there. Notice the red arrows pointing to lines. That's the topography of the present Earth at present there. This is how irregular erosion is. The contrast between those wavy lines and the flatness of those layers tells you the issue that we're raising right here. And that is, why are those things out there so flat? Why are they so widespread? That's just what you'd expect during the Genesis flood if those layers were laid down rapidly, and certainly not what you'd expect if those long geologic ages took place and those paraconformities represent development of layers in other regions. Finally, I just want to draw this implication for creation. One does not have to give up his scientific integrity in order to believe in the biblical account of beginnings. There's significant data that supports the Bible. While the scientific literature overwhelmingly rejects the biblical accounts, there is good data that supports it. And I'd like to suggest, as an implication, instead of focusing too much on the question, how should we live with the dissonance between science and the Bible, which is the question I asked you at the beginning, we should be focusing more on how can we live with the dissonance within science, because there's a lot of scientific data that supports the biblical model of creation. Thank you.